In this video, we will graph this rational function right here. Alright, we're being asked to find the x-intercepts of this function. And looking at our notes here, we remember that to find the x-intercepts, we can find the zeros of the numerator. In other words, set the numerator equal to 0 and solve. So that's what I'm going to do. So if I set the numerator equal to 0, so that would give me 3x plus 1 equals 0. Subtracting 1 gives me 3x equals negative 1. Dividing both sides by 3 gives me x equals negative 1/3. So that means that the x-intercept is going to be negative 1/3, comma 0. And we might as well graph that on the graph right now. It'd be right about here. It's right next to the origin. Negative 1/3 is just a third of a space over and on the x-axis. So that's my x-intercept. How about the y-intercept? If you want the y-intercept, you're just going to plug in 0 for the x's. So you could do that by hand pretty easily. If you want the y-intercept, one way of doing it is just plug in 0 for all the x's. If you do that, then if this is 0, then that term is gone, and this term is gone, and this term is gone. So that's really going to just leave 1 over negative 6, or negative 1/6. Okay, so that's what you wind up with if you plug in 0 for all the x's. Is really just this part is left. So that's why the y-intercept is going to be 0, comma negative 1/6. Notice that I'm not using decimals here. I don't want any decimals. If it's going to be a fraction, let it be a fraction, but do not give me a decimal. Now, say if you didn't remember about plugging in 0 for the x's, and you wanted to use your calculator instead. Here's what you would do. You would type the function into your calculator. Okay, so I'm going to have 3x plus 1 over x squared minus x minus 6. And I'm just going to use ask x mode for now. So if you want the y-intercept, all you have to do is let x be 0, and then you have the y-intercept. So you see I have 0 and negative 1/6. Okay, and so that's the same thing we got by hand. So that's my y-intercept. So I might as well graph that as well. Okay, 0 and negative 1/6. Well, negative 1/6 is a tiny amount down. So again, that's virtually at the origin. So I just have these 2 points next to the origin. So let's keep going. Next we have vertical asymptotes. How do we find vertical asymptotes? You find the zeros of the denominator. In other words, set the denominator equal to 0 and solve. So let's do that. So the vertical asymptotes are going to come from the denominator. If I set x squared minus x minus 6 equal to 0 and solve, I'm going to factor this. So that's going to be, so x squared will be x times x. 6 is either going to be 2 times 3 or it will be 1 times 6. Alright, the middle has to be negative 1, so I'm going to try the 2 times 3. Remember that inner plus outer equals middle. Inner, I have 2x. Outer, I have 3x. If I want to get a middle of negative 1, I need positive 2 and negative 3. That makes negative 1. So positive 2 and negative 3. Also, that makes negative 6. Positive 2 times negative 3 makes negative 6. So this is how you factor it. And so to solve it, I need to set these equal to 0. So if I'm setting x plus 2 equals 0 and x minus 3 equals 0, I'm going to get x equals negative 2 and x equals positive 3. So that's how you find the vertical asymptotes. X equals negative 2, x equals 3. Notice, do not just put 3, put x equals 3. Do not just put 2, put x equals negative 2. Don't just put negative 2. We might as well draw those asymptotes while we're at it. So these are vertical asymptotes. Okay, so we're going to draw vertical lines at negative 2 and make them dotted lines, not solid. And we have a vertical asymptote at 3, so that'll be over here. Okay, now it's time for horizontal asymptotes. So horizontal asymptotes, you have to follow these 3 rules. Horizontal asymptotes depend on the degree of the numerator and how it compares to the degree of the denominator. If the degree of the numerator is less than the denominator, then it's y equals 0. If the degrees are equal, then it's y equals a over c, where a and c are the leading coefficients. If the degree of the numerator is greater than the denominator, then there is no horizontal asymptote. So it's all about the degree. If you look here, we see that the degree of the numerator is 1, because this is just a plain x with no exponent, so that's a 1. Down here, the degree is 2, because I have x squared. So I have degree 1 and degree 2. So the degree of the numerator is less. And when the degree of the numerator is less than the denominator, that's when the horizontal asymptote is y equals 0. Alright, so it's very important that you memorize those rules. So y equals 0. Don't just put 0, put y equals 0. And y equals 0 is the x-axis. So go ahead and draw this dotted line. Okay? I think we should go ahead and draw the graph before we try to do the domain or range. Even though technically I could do the domain right now just based on the vertical asymptotes, we'll go ahead and draw the graph. So we need to decide what values we're going to use for our x values. So I'm going to do that on scratch paper. I'm going to make that decision, and that's something that you could copy. Think and decide ahead of time which x values you're going to use. It's all going to be based on the vertical asymptotes. Each vertical asymptote is going to give you 4 x values that you are going to want to use. So in this way, my first vertical asymptote is negative 2. So watch how I get 4 values out of this. I need the decimals a half of a unit to the left or right of negative 2. So if I go to the left of negative 2 on a number line, half of a unit, that would be negative 2.5. If I went to the right of negative 2 on a number line, that would be negative 1.5. Alright, so I have those 2 values. Now, I'm going to get 4 values from this. So I'm going to keep going to the left, and I would hit negative 3. If I kept going to the right, I would hit negative 1. So these are the 4 values around negative 2, including the decimals 1/2 of a unit to the left and right. So I'm going to use these 4 values for sure. Now my other vertical asymptote is going to give me 4 more values. Okay, so my other vertical asymptote is 3. So take a look at that. And I'm not sure I have enough space. Can I squeeze it in? I'll try. So if I have 3, okay, maybe I'll use a different color in case they get too close. So I have my vertical asymptote of 3. I need the decimals to the left and right of 3. Less than 3, a half a unit would be negative 2.5. Not negative, I'm sorry. It would just be 2.5. To the right of 3 would be 3.5. All right, but I need 2 more values. So if I went to the left further, it would just be 2. If I went to the right further, it would be 4. So this gives me 8 values that I can use. Okay, so let's see. How many spaces do I have on my chart? 1, 2, 3, 4, 5, 6, 7. So I really want 8. I really want it. So I'm just going to stretch this out to make room for the extra value. Okay, so I'm just going to pause the video and copy all these values onto my chart. Okay, so here I've copied all of those values onto my chart. Now I need the y values that go with them. So I am just going to use the table feature of my calculator here to make that happen. Okay, make sure you're in ask mode. So I need -3, so I will type in -3, and I need -2.5, so -2.5, and -1.5. Alright, so I get these weird looking fractions. I really need decimals over here for easy graphing. So I'm going to come over here and I'm going to convert each one of these to a decimal by hitting the toggle button. Boom! So that's -1.3. I'm just going to round everything to 1 decimal place. So -1.3. I move down to the next one, toggle that as well. That's -2.4. I'm going to round up because the next number is a 6, so -2.4. And I'm just going to go ahead and find all of the y values in a similar way using the ask feature of my calculator. You don't need to watch me do those one at a time. I'm just going to do it off camera. Alright, so I've gotten all these points, these 8 points. Now I'm going to take these 8 points and I'm going to plot them on the graph. Okay, so you can see by these green dots are all these points that I have plotted. In addition to remember these dots right here close to the origin were the x and y intercepts. So looking at these dots, I need to figure out how the graph is going. So for example, looking at these 2 dots over here, I know the curve has to approach the horizontal asymptote as I go to the left. So as I go through these 2 points, I know it's got to approach the horizontal asymptote, so it's got to go like that. Alright, my graph, sometimes they disappear. I'm not sure why. Meanwhile, on the other side, I know it has to approach the vertical asymptote, so I know it's going to be doing like this. Alright, so that's what that branch is going to look like. Similarly, these 2 dots over here in the upper right hand corner are doing the same type of thing. I know that it's got to approach the horizontal asymptote, so it's going to be going like this. And I know that it's going to approach the vertical asymptote, so I know it's got to go like this. So that's what's happening over there. And it's disappearing again. Okay, now looking at the middle portion, don't get worried about the fact that these dots, some of them are on the horizontal asymptote. And you see that some dots are above and some dots are below. So if it looks like the the function is crossing over the horizontal asymptote? That's because it is. You can cross the horizontal asymptote. The horizontal asymptote is not like a brick wall. That's what the vertical asymptotes are. The vertical asymptotes are undefined. So you will never, ever, ever find any points touching the vertical asymptotes. But the horizontal asymptotes are really just showing you the end behavior. So they're just showing you on the far right where the function is going and on the far left where the function is going. In the middle, it can be crossed. So that's what's happening here. I can see, looking at these lower points, as I connect these dots sort of like this, I can tell it's going to go ahead and approach the vertical asymptote. And similarly, if I connect these points, I'm moving in this direction, and I know it's going to go on to approach this vertical asymptote as well. So it's going to approach that asymptote, and it's going to approach this asymptote. Even though it looks like it's touching, in your mind, just know that it's not really touching. I don't know why it keeps disappearing. I'm going to see what I can do about that. Okay, so we've drawn the graph. This is what the graph is going to look like. Now let's go back and answer the rest of these questions. The domain. The domain is how far the graph goes from left to right. It's the x values of the graph. And look at the vertical asymptotes. The vertical asymptotes are dividing this graph into these three parts. If you look at the x-axis as you go, this branch down here goes from negative infinity to the first asymptote. Okay, strictly looking from left to right, not up and down, just scanning across the x-axis. Maybe I can mark this off with a highlighter. This graph begins over here, all right, but it goes forever, so that's negative infinity, and it ends right here. This piece goes from negative infinity to -2. All right, so that's the first part of our domain, is going to be negative infinity to -2. All right, now the middle portion. The middle portion, from left to right, it goes from -2 to +2. Yeah, it goes up in the air and it goes down to the ground, but we're not going to talk about positive infinity and negative infinity because we're just talking about left to right. So it goes from the first vertical asymptote over to the second vertical asymptote. -2 to +3. Okay, and that leaves this third portion. But we're only talking about the x values, how far it goes from left to right. So it picks up at the second vertical asymptote, which is at 3, and it goes forever to the right. So that's going to be 3 to infinity. Okay, so that's the domain in 3 pieces. And I really could have done the domain as soon as I knew the vertical asymptotes. I could have done the domain immediately. So I had -2 and I had 3. Those were my vertical asymptotes. So I should have known that the domain would be negative infinity to -2 because of this, and then -2 to 3 because of both of these, and then 3 to infinity. You really can get the domain just from the vertical asymptotes, and then union, union in between. Now the range is not so simple. You can't base the range just on the horizontal asymptote, for example. You really have to look at the picture. So the range represents the y values of a graph. How low does it go? How high does it go? Is anything skipped? Well, if you just look at this middle portion of the graph, look at its y values, you'll be able to answer the question. Because in the middle portion, notice that this graph goes up forever and it goes down forever, and there's no break. Remember that it crosses over the x-axis here, so there is no break. So we don't need two separate parts to the range. We're not going to do a separate range for the three branches. We're looking at the function as a whole. We only had to do three separate pieces to the domain because these vertical asymptotes are not being crossed. So vertically, it really is separated into three separate pieces. All right, nothing is crossing the vertical asymptote. But because we have this one piece that crosses over the horizontal asymptote, we don't actually have separate pieces. It's unbroken from top to bottom. So the range is negative infinity to positive infinity. It goes down and up forever, unbroken. Unbroken. Okay. Now let's talk about increasing and decreasing intervals. From left to right, let's take this one portion at a time. This first branch over here, from left to right, this is going downhill. So this is a decreasing interval. Now we're only doing x values for both of these. So this decreasing portion, it comes in from negative infinity and it continues until the first asymptote. So this is decreasing and it goes from negative infinity to negative 2. Now, then it picks up here. And from left to right, this is also decreasing. So this entire wave is decreasing. And looking at the x values, it goes from asymptote to asymptote. So negative 2 to 3. And then it picks up here. And from left to right, this is decreasing as well. So it's from left to right, it's picking up from the vertical asymptote, and it goes to the right forever. So that's going to be 3 to infinity. So every part of this graph is decreasing, 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 and decreasing. So there are no increasing intervals. Okay, now let's talk about symmetry. This is trying to be odd. So the options are even, odd, or neither. Now this is very close to being odd, but not quite. Remember, it's odd if it looks the same when you turn it upside down, exactly the same. And it almost does. You know, it's very similar. If you turn this upside down, it would be hard to see that it's not quite the same. So you'd be forgiven. I mean, you know, you're going to lose. If you called this odd, here, let me tell you why you would lose points for that. It's not quite at the center. Okay, remember, for example, the x and y intercept do not go through the origin. It's not centered at 0, 0. It's crossing the x-axis here just a little bit to the left and a little bit below the origin. All right. If this were going to be odd, the x and y intercept here would be 0, 0. It would go dead center. So we're going to have to go with neither on this one. And that's it for this function. All right, that was a lot of information. I hope it was helpful.